Welcome back to the channel. In this lecture series, we have been looking at quantitative ability problems from Vqar. So, in this video, we'll be looking at both and streams. So, just a slight introduction to boats and streams problem. It is that these sort of problems study about relative motion of boats and water currents. So, to find out where it has, where the boat has to land and from which position it is. So, it will be involving some sort of some amount of physics, trigonometry in mathematics as well. So, it calculates speed of the boat in still water and stream. So, the important concepts that we'll be needing to solve these problems will be like the physics as well as physics, directionality, and mathematics, and we have to apply the trigonometry, engineering, and navigation in this. So the basic concepts and terminology are that first thing, speed in still water. Both speed without current is speed in still water is equal to upstream plus downstream divided by 2. So followed by that, we have speed of stream. Speed of stream is the speed of water current. Speed of stream is equal to downstream minus upstream divided by 2. Okay. For still water, it is the sum of downstream and upstream divided by 2. For speed of stream, it is downstream minus upstream divided by 2. The downstream is nothing but moving with the current. Downstream is speed in still water plus speed of stream. Then we have upstream where the moving against current. We are going opposite to the current. So for this, the upstream speed will be speed in still water minus speed of stream. So to just simplify, uh, upstream is nothing but moving against the water current. So we are going against the water's flow. So we have to give extra force to it. Extra, we have to give more speed to go against that. Downstream is going along with the current. So we do not need to we do not need speed. The speed of the water flowing is the speed that is enough. If needed, if we want to go faster, we can add on to it. So it will be adding to the already existing water stream. So first thing is to empathize. Okay, understanding the problem. So the to identify the real world challenges in boat navigation. So we'll see some of the tips and tricks to find out these sort of problems, downstream and upstream problems. So we have to firstly we have to see is the direction of boat and the direction of stream. They both are the same side. For upstream, it is direction of boat is opposite to direction of stream. So this is the basic idea. So we have to observe the context where the boat's interaction with water current and the stakeholders in this are the sailors, engineers, maybe like boatsmen, students, etc. Then the key insight is to navigate efficiency. So we have to find out the navigation way to navigate the boat across the stream. So the relative motion between boat and water is the thing that we have to consider to calculate. Next is to define the problem. So we understood that what is speed with respect to downstream and upstream. So we have to analyze the findings. Um, so first thing is speed of boat plus speed of stream. If you are going downstream, if you're going upstream, it is speed of boat minus speed of stream. So the core challenge will be to how to make both stream problems more intuitive and easier to solve, so that the students are able to answer these aptitude problems easily. Next thing is ideate. So generally, multiple approaches to there are different ways to solve both stream problems. Even if we get to like aptitude problems, there are multiple ways. So first basic way is to solve it, or the other way is to eliminate the wrong answers. So we'll first try with the solving method. Okay. Then what are different perspectives? To identify different perspectives, we need group discussions with diverse students. So to get their different opinions and then to solve that, and then to see what are the different ways to solve that. So to get creative approaches, It will be better to have visual models, analogies, and some real world examples. Solution categories are like visual learning tools, interactive simulations, and problem solving frameworks. So we have seen the downstream and upstream here, right? Next thing is to prototype. So in prototype, we have to create tangible models to develop visual representation of both stream concepts, the downstream and the upstream concepts. Then we have to go with the experimental setups, the physical models demonstrating relative motion and which show the actual problem and what are the data within that. Then the interactive tools give us the data, and when we simulate, when we try to I mean, change the values, it should show the simulation of, um, it should show the changes in that, and so the simulation should show how the change in data works. The next is prototype types. It can be the visual diagrams, mathematical models, or physical demonstrations and simulations models, etc. Next, for design thing, next stage is test. So testing is to give the student numerical problems and testing that. So let's test with an example. So let's say both man or boat's speed is x, and the stream or current or reverse speed is y. So downstream is x plus y and upstream is x minus y. We already know that. So it is given that x is to y is 7 is to 1. So x is equal to 7 into y. So speed equal to distance by time, we already know that. So upstream speed is 4.2 kilometer by 14 minutes. So it gives us zero point 0.3 kilometer per minute, right? Then upstream speed is, we already know that upstream speed is x minus y. So that is 7y minus y. So it is, we get it, it is obviously equal to 0.3 kilometer per minute. So we get y equal to 0.05 kilometer per minute. Okay, downstream speed will be x plus y. The formula is x plus y, right? So downstream speed equal to x plus y. We know that x is equal to 7y. So we get 7y plus y equal to 8y. So finally we get 8 multiplied by 0.05. We get 0.4 kilometer per minute. So downstream time is distance by speed equal to 18.4 kilometer, that's the distance, divided by speed as 0.4 kilometer per minute. So the time taken will be 184 by 4 equal to 46 minutes. So the time taken for downstream, for the, I mean, boat to travel downstream is 46 minutes. So here we have a representation of the mind map. In the mind map, you can see that we have boats and streams. So the concept, we split into basic concepts, decision thinking process, and application and value. So in the basic concept, we have still water speed, speed of stream, upstream and downstream, and then relative motion. On the other side, we have applications where these applications will be navigation and engineering, fluid dynamics, analytical thinking skills, physics, and mathematics. We are looking at still water speed, both speed without current. Formula will be the still water speed is for the formula is upstream plus downstream divided by 2. Speed of stream is water current speed. So the formula for speed of stream is downstream minus upstream divided by 2. Okay, so downstream is nothing but moving along with the current, and if you have the both speed adding to it, it adds to it. If it is upstream, you are going against the current, so naturally it is both speed minus the stream speed.